Here's the uncomfortable truth. A lot of RAG systems are not bad because the model is weak. They're bad because the vector search is scoring similarity the wrong way.
Exactly. In FAISS, the choice between L2 distance and inner product is not a tiny implementation detail. It changes which chunks get retrieved, which changes what your generator sees, and that changes the answer.
So this is not a math purity argument. This is, do you pull the right evidence, or do you quietly sabotage your own pipeline?
Right. And the trap is that both options can look reasonable in code. You can build an index, run queries, get results, and still be ranking the wrong neighbors.
Let's make it concrete fast. What does L2 distance actually mean in plain English?
L2 distance is straight-line distance between two vectors. Picture each embedding as a point in space. Smaller L2 means the points are physically closer together. FAISS treats the nearest points as the best matches.
And inner product?
Inner product is more like alignment. It rewards vectors pointing in a similar direction, and it also cares about magnitude unless you normalize. Bigger inner product means a better match.
So 1 is closeness, 1 is alignment. That sounds subtle, but not deadly yet.
It becomes deadly when your embedding model was trained with one similarity idea in mind, and your index uses another. Then your retrieval score stops matching what the embedding space was built to represent.
Give me a RAG scenario where that mismatch bites hard.
Say you store support docs for a payments product. A user asks, "Why was my payout delayed after bank verification?" Your embedding model expects cosine-style similarity, which in practice usually means normalized vectors and inner product. But you index raw vectors with L2. Now documents with larger vector norms can shift ranking in weird ways, and a doc about general payout timing might outrank the specific bank verification article you actually need.
That's the nasty version of failure, because the system still returns something plausible.
Yes, you do not get a crash. You get confident irrelevance. And in RAG, plausible but wrong context is often worse than no context, because the language model will build on it.
Okay, let's pin down the matching rule. How should programmers think about metric choice without turning this into a linear algebra seminar?
Use the metric your embeddings were designed for. If the model documentation or training setup assumes cosine similarity, then normalize your vectors and use inner product and FAISS. If the setup assumes Euclidean closeness, L2 can be the right fit. The metric is part of the embedding contract.
And if I ignore that contract?
Then, you are changing the meaning of similarity after the fact. It is like using a ruler to score things that were trained to be compared by angle. You can still measure, but the ranking no longer reflects the model's intended geometry.
There's also a common shortcut here. People say cosine inner product, same thing. Is that true or sloppy?
It is only true after normalization. If every vector is scaled to unit length, then cosine similarity and inner product give the same ranking. Without normalization, inner product also rewards magnitude, so longer vectors can win, even if direction is not the best semantic match.
Let's do another example, because this is where teams lose weeks. What would that look like in a document retrieval pipeline?
Imagine a legal RAG system. You embed contract clauses and user questions. Two clauses are both about termination, but one vector happens to have a larger norm because of how the model encodes the text. If you use raw inner product, when the workflow really needed cosine-like comparison, that larger norm clause can dominate the score. The system retrieves a broader termination clause instead of the exact early termination exception. Now the answer sounds polished and is materially wrong.
So the winners and losers are not random. The wrong metric systematically favors the wrong shape of vectors.
Exactly. Metric choice creates a bias in retrieval. Some documents become artificially privileged, others become invisible. That affects precision, recall, and trust in production.
What should a builder actually do in FAISS when setting this up?
First, check what your embedding model expects. Second, if it is cosine style, normalize both stored embeddings and query embeddings, then use an inner product index. Third, evaluate retrieval with examples that matter to your product, not just average benchmark scores.
Not just top-line metrics, because a small scoring mistake can hit the exact queries that are business critical.
Right. In RAG, failure clusters around edge cases with high stakes: refunds, policy exceptions, medical details, legal carve-outs, internal runbooks. That is where metric mismatch shows up as costly confusion.
One more practical tell. If someone says, we swapped FAISS metric types and nothing exploded, what's your response?
I'd say that proves almost nothing. Retrieval bugs are often silent. Run side-by-side tests on real queries, inspect top K differences, and look at downstream answer quality. The right metric is the one that matches the embedding setup and wins on the queries you actually care about.
So, the real lesson is that similarity is not a default. It is a design decision with consequences.
Exactly. In FAISS, L2 means nearest by distance. Inner product means most aligned. And with normalization, it behaves like cosine. Pick the one your embeddings were built for, or your RAG system will retrieve with confidence and fail with style.